A special type of AC method that we can use is difference of squares, because this doesn't look like it has three terms, but what I'm going to do is I'm going to put a 0 in the middle as a placeholder. So I'll slide the minus 9a squared over, and I'm going to put a 0ah in between. Okay, now it looks like it's got three terms, and I can apply the AC method out of this. So 16 times negative 9 multiplied to give you negative 144. But these two factors have to add to give you 0. Now, if you use a little bit of number sense here, when numbers add up to give you 0, they have to be the same exact number but opposites. Now, can you think of two numbers to multiply that'll give you negative 144 that'll add to give you 0 that are the same number? In this case, it's 12 and negative 12. 12 times negative 12 is on negative 144. 12 minus 12 is 0. So there's the two numbers that I'm going to put in the middle. And I go through my factor by grouping steps. The first two terms, 16h squared and 12ah, they both have a 4 and an h that goes into them. So what I have left over is 4h plus 3a. If I look at the second two terms, what they have in common at most is a negative 3a. Okay, they're both negative numbers, so I can factor out a negative out of them. They also share an a at most in common, so I have that second parenthesis that's 4h plus 3a also. I factor out the common parentheses and I group up the parts that are on the outside. 4h minus 3a times 4h plus 3a. Perfect squares. Go through and factor these out, and I see that between all three terms, they do not have anything in common, so I go through step 2. 4 times 9, we're looking for two numbers that are going to multiply to give us 36, that add to give us that middle term of 12. I start listing out my factors, 1 and 36, but when I add them up, I get 37, so that's not 12. 2 times 18, 2 plus 18 will give us 20. We're getting closer. 3 and 12 is 36. 3 plus 12 is 15. Again, we're getting closer. And then we get 4 and 9. 4 times 9 is 36, but 4 plus 9 is 13, so that's really close. But the last combination that I can come up with is 6 times 6 gives us 36. 6 plus 6 is 12, so those are the two numbers that I'm going to use. I take a 6 and the other 6, and I replace the 12 with a 6y plus 6y, and I go through and do all of my grouping steps again. Between the first two terms, they have a 2y in common. So after I factor 2y out, I have 2y plus 3 remaining. The last two terms, 6y plus 9, they have a common factor of a positive 3. So I get my second parenthesis to match up. I factor out my common parenthesis, and I have 2y plus 3 times 2y plus 3. Now I've got two of the exact same parentheses. Now what I want to recall, though, is our product of like terms. If I have a times a, the rule of exponents says that that's the same thing as a to the second power. So I only have to write my base once with the power of 2. Here, my base is a 2y plus 3. Those are considered the same thing. So I can push those together in a sense and just write one parenthesis of 2y plus 3 raised to the second power, because that second power means that I have two copies of that parenthesis. So that's a perfect square. The last thing I want to talk about is something that's in a quadratic form. My powers are bigger, but it's set up the same way. So if you see x to the fourth power and x squared, don't freak out. You can still use it with the AC method. If I look at each term, they're all even numbers, so I know that there's a common factor between all of these. I factor out the 2. So what I have remaining is 9x to the fourth plus 12x squared plus 4. And I'm going to focus on the inside the parentheses by doing my AC method. So 9 times 4, 36. So again, we're going to look for multiples, numbers that multiply to give me 36, that add to give me that middle number of 12. The two numbers that I can think of, again, are 6 and 6. So just on the inside of that parentheses, I'm going to replace the 12x squared with not 6x plus 6x, but because that term is an x squared, I'm going to write 6x squared plus 6x squared and do the grouping for that polynomial. So between the first two terms, 9x to the fourth and 6x squared have a 3x squared in common. What I have remaining is 3x squared plus 2. And what 6x squared and positive 4 have in common is a positive 2. So the second parenthesis matches up. I factor out the like parenthesis. And again, you see that I have two parentheses that are exactly the same. And the 2 that I factored out at the very beginning also has to be reintroduced into the problem. But since the parentheses are exactly the same, I'm going to put those together and write them to the second power. So I have 2 times the square of 3x squared plus 2. So that's the AC method.